to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi there, Testing Gil here, and I have some bad news and some good news. The bad news is that I can't come to TestCon this year in person. And since I've heard so much about it, it's really a big deal to me. But the good news is that I'm going to present it remotely. This is going to be a whole new talk called the Quality Dashboard. I know, it sounds boring, but listen. This is a real case study of how to build reports and dashboards about quality metrics that are useful, not just for managers, but also for developers and the testers. It's how I implemented it in a big company and what the results were. I hope it will inspire you to build your own. So join me on October 14th at TestCon. Live long and test.
Hey everyone, thank you for coming today. My name is Gil. I'll be your host for the next 40 minutes or so, and we're going to talk about the quality dashboard, which is a bit of a light. There's no dashboard yet, but there are a couple of reports, and I'm going to walk you through a story of what I've been through with the team working for the last something like 6 months or so, even more than that, producing quality reports that are not the regular that you see every time. So that's going to be the story. It is a story. It's a long one. Get some coffee. It would be nice to have something. And while I'm talking here, and before I start, who am I? This is my first time at TestCon, and I wish to be there like in person. Maybe next time. My name is Gil Zilberfeld, Testing Gil. I'm in Israel. I'm recording this in Israel. I'm a consultant, and I work with the development teams and test teams on everything from test automation to unit testing and TDD, code quality and clean code, and test planning, and anything regarding the process of testing. And this is basically how I came to be on this team, which I'm going to expand on a minute. What else can I tell you? You can reach me at testinggil.com. There's a lot of stuff, content I put there, and gil@testinggil.com on email and on Twitter. So a long time ago, which my story actually starts more than a year ago, something like that. As a consultant, I was invited to work with a team in a bank, and maybe you know, maybe you didn't know, development teams in banks, like they're very big, many of them. I was invited to teach and help people automate their API tests. That was the beginning. So I was working with them something like 4 or 5 months, learning how they work, trying to accommodate things in terms of processes of how they can test better. And then I was invited to talk about measurements. So let's talk a bit about the beginning point of this story, because it really is important. So, like I said, I was working with the REST team, the API team. They were writing API in Java, mostly talking to the backend, the mainframe, but also writing their own logic and new stuff. And then we're beginning to do that, this transformation. I was helping with that. There was no way to measure what they were doing. So there were no automated reports or something like that. There was obviously CI, Jenkins was running their tests. There were no real report apart from Jenkins and JUnit and Jacoco code coverage saying this is how we're doing. And even a bit more than that, which APIs were tested and which were not, they couldn't tell. They did this manually. And through this team and other teams as well, there came the understanding that we want to show a flashlight on what they were doing, because management wanted to know, and the teams themselves wanted to know how they were doing. One more thing that will help our story soon is that they just installed SonarQube. A bit about the culture. They call themselves Agiles. Up to this point, I wouldn't say they are. Yes, there are teams, small teams. Some of them even have DevOps in them, but they don't have testers in them. So it's not a full Agile team. There are no product managers, really. There are architects that tell the dev teams what to build. So the culture is not really agile, but it is striving to be. There is a great DevOps leadership. Some of the methodology, for good and bad, came from them of how to work. There's an old school management, because it's a bank, and banks are like that. They want to control, but they also want to lean towards Agile and give the teams ways to independently improve. And this is very important for us, because we were given a mandate to do just that. So at the beginning, like I told you, basically what management wanted was more information and more reports. They wanted to know how the teams were doing, and the teams out of the box could not provide this information. So this is how we started, how the measurement squad, as it calls today, got drafted. Management understood that there's a place for a team that will help the development teams show how they were doing. So at the beginning, the squad was very small squad. So they drafted a team lead and a programmer. Both of them came from data sciences background. And at some point in the future, we probably will delve into that as well, but not today. And there was me. I came in as an expert, let's say, because I had, and I still have, a lot of experience in testing and unit testing, like I said, everything in the beginning. But also through these 4 or 5 months, I actually learned how some of the teams were actually writing their tests and their code. So, and this was very important, because we could focus on things that I said, these are things that I want improved, and therefore we should show them in reports. Later on, in the last couple of months, they added like a project manager that will help smooth things out, and a second programmer. Now, obviously, management wanted more goals, but they didn't know what to ask for. And usually when people ask, development teams, they ask them for coverage. This is what people know what to ask. But other than that, there was no real metrics. So we kind of were independent of selecting what we want to shine a light on for ourselves. Again, very important because we want to bring to management useful reports. That means that they can look at the reports and ask questions for the teams about, well, how can we make this better? But we also wanted to give the developers things that they could fix. It's not like just showing you have 85% coverage overall. What do I do with that? We don't know. So we want to give the developers a list of fix the things that were useful as well. Useful or in terms of what basically the team, with my help, decided are really useful. And that was a focus on effective tests and clean code. Why? The main thing up until today, and it will continue to do that, is looking at the effectiveness of developers and the teams in general. They don't have all the time in the world, and they need to spend it on things that will matter. Things that when they fix them, problems that they fix or do more of, the valuable time will be used more effectively. So my glasses in that case were always looking about metrics that will improve the lives of developers in terms of making them more effective. So for every experiment, you need a guinea pig. Sure, we could go forward and just produce reports, but we want to test the entire cycle, meaning we bring reports, we give it to teams to look at, get feedback, and fix things. And we needed an experiment. For our experiment, we needed a guinea pig like that. And this was a small team, basically a project manager and a single developer at the beginning. We moved out and branched out later. But this was a team that were willing to look at the results, what we gave them. They were willing to fix the errors that we found. And we learned a lot about the cycle time, the cycle of giving the reports out and fixing them and so on. And this taught us a lot. Then we moved on to other projects as well. So that's basically the premise, not too ground shattering. Let's talk about what we actually started to measure and look at. So like I said, SonarQube was installed early on. And usually you just look at it, the high level metrics, and we connected at it and brought information out. But one of the things that started out was fixing the code messages to code errors. But for that, I personally took a couple of days to just look over the rules that SonarQube gives you out. There's a lot of information there, some of it good, some of it, a lot of the rules are just things that will probably never happen, like in Java, for example, or in modern Java. Again, looking at the thing that if they fix it, will that save them time or will it make the code much more readable? And I threw out a lot of the things. And that was the basic list of rules that we started producing reports on. We pulled, using the SonarQube APIs, a lot of things like reliability and tech debt maintenance, everything that SonarQube calculates for itself, but we want them to put them in one report. One thing I lost a fight for was putting the tech debt in there. People who don't know, tech debt is a calculation that SonarCube does while calculating all the errors that it has and calculating the time that it will take to fix that. And this is so not tech debt. If you want, there's a whole separate talk about what tech debt is I can give. Ask me later. But like I said, some of the things were so easy to provide and start getting the information in and getting a discussion on. So this is still in the reports. This is what the report looks like for the SonarCube. You can see like colors, and we had one for each project. Reliability, the depth and the complexity, also gave it over trend. You see that what you see here, for example, is something that you'll see in many teams starting out, which is a trend which is kind of like this, which until they get hammered into their head that is good for them, they wouldn't do anything about it. So trend was also important. Explaining what it means is very important, so you can give out like ranges and numbers, so we can color code it. And this is where the green and the red come from. And the explanation there in the report every time, very important, so people will learn what it means when they read it and what to do next. And what you saw basically was the management report. Apart from that, we gave a full report for the developer, what the errors that we found are. So that was the SonarCube thing. It still goes on, but this is not worth a talk. We talk about other stuff. And this is something that we went into without knowing much about, but kind of came up with a few knowledge bits that you might find interesting. That's about documentation. So like I said, the teams were writing APIs, and the way the process works is that the Swagger documentation gets created automatically from the code, not the other way around. So many organizations do that differently. They create a Swagger definition, then produce the code from that. But because of the process, which is kind of the other way around, we started looking about what we had. So we had tests running APIs, and we wanted to see if the things that were documented were actually exercised. So this is starting to be more interesting. So we compared actual API invocations in the tests to what was documented. So like running the tests, and in runtime, we get information about what ran with what parameters and how it compared to documented Swagger. And we learned a couple of things that we didn't really intend to. So this is an example of the API, and you see on the left, in the middle, untested responses. There were tests that were not testing the responses that were documented on the Swagger. And on the right-hand side, you see things that were run in the test, and they received like 207 for the first API, but was not documented in the Swagger. So we had kind of an integrity problem, and this was kind of interesting to learn. So how do we do that? Actually, we needed tests, obviously, but at the beginning, we needed to add some logs to the test that weren't just coming out of Java and Spring and Jenkins. So the person in the guinea pig experiment added some logs that were not just out of the box. Then we passed those logs after runtime, identified the tests and the APIs that were invoked by the URLs, and then went there and with the API working towards Swagger, we compared them and we matched them and you compare them. So that's how we created this kind of table. One more thing that is interesting is that you can do with the documentation is ask how much should you test. And we thought about one way to show that. So we had tests, but are they good tests? Are they good enough tests? Do we need to write more tests? Do they cover all the code? So this is a black box. All we know about is the signature of the API. So we took heuristics and we decided that we'll count the parameters in an API. And basically for each parameter, we'll decide, well, for each parameter, we want two cases. One for valid, one invalid, at least. Okay? Again, a heuristic doesn't have to work anyway, but we assume that if you pass a parameter, there's going to be a valid and invalid case. We don't know what it is. We don't understand the code. We don't understand the business. But we expect to count tests as a function of the count of the number of the parameters. If one of the parameters is a default, we said it's going to be like 3 cases. So if you combine it like 2 times 2 times, I don't know, 3, you get like 12 test cases. If you get a look at the example at the bottom, you have a get method with get address by ID. The ID could be, you can write a lot of things with ID, but at least you'd want, in terms of black box, trying to get something valid, invalid. What is valid? I don't know. I'm assuming 1 will work. I don't know. I'm assuming -1 will do something else, but I'm not the developer. I'm giving them the report to say, well, we're missing at least a case here if we counted 1. And we provide something like that. So you'll see the blue ones are the required tests, the ones that we calculated that the number that we assume based on the number of parameters, as well as the status that it returns. What are the cases that we're looking for? The orange ones is tests that were actually exercising these APIs. So you can see for the update agreement one, for example, we had required number 4 cases, and there were actually 4 cases written. But then we discovered that the API was called more times than they were documented, which was very interesting. So can I show this together? You can see other things there were not even tests written to. So, and obviously there was no undocumented things. So this is a cool one. And we started looking at this, we started putting new metrics in, like Swagger documentation integrity based on these numbers. How much is required, how much is required plus undocumented that we found. We said this is like a percentage between 0 and 1 that you can actually show. So that was following SonarQube, the second step there. And we started, in the meantime, when we started looking at the documentation, we also started looking at the tests themselves. So there were a few things that like I said, learned about how the team's writing code and tests, and I wanted to show them. The first one, the ignore tests, it's probably already there, right? Yeah, you get a JUnit report, you'll see how many people were ignored, how many tests were ignored, not people. And you can do something about them, but we wanted that in that report. So that was like easy, like drinking it from Jenkins. But now we wanted to start talking about what kind of tests. So basically, one of the things that I've learned is that people are writing a lot of API tests, but not enough unit tests. So I want to show that. And for that, comparing it to the test pyramid, we needed to test to identify which tests they are. And you can't really do that from a JUnit report. So we needed to understand what the tests are actually testing. We can do it. We can't really do it. We could do it like dynamically, but we could identify the API tests only on one environment, not on the CI level. So we couldn't really tell without a lot of work how to separate unit and API test. Plus, there's other things that people started to write, which are like unit tests, but are more like Spring tests. and they are different because they're not API tests. And one more thing that we looked at is the assert count. There's going to be a separate slide for that as well. So we needed to know more about the test, and this is how the test analyzer was born. Test analyzer is a tool that we've written in Java, basically to parse test. You can find the open source version at the end of the back slide, but we did a lot of custom things for how the code is written in the bank, so that's not out there. But some of it, including the assert things, is in the open source version. Let's talk about asserts. How good is your test, right? As good as your assert. So obviously, you know that if you didn't write any assert, this is not a good test. But that's not all. So if you check something for assert not null, it could be improved, like assert not null on equality. Assert not null A equals B. So assert not null on, not inequality, assert not null on something that was returned, you can basically call a method on it on another assert and check that if it returns something. If it is null, it will fail, obviously. But a lot of the things that I saw before that was that if you call an API and you get a response back, people would check assert not null on the body. And in a lot of the cases, the body would never be null. And people would just use that assert not null on the body instead of just checking things that the body will return. And like I said, if most of the cases, because of serialization issues, an object will always be returned even if it was not containing the right stuff, people would just missing out on better asserts. So again, we gave a criteria to tests. For unit tests, we said one assert at least is okay. And for APIs, we assume there's going to be a status check, like the HTTP status, if it returned okay or something like that, and something on the body. Again, they need to be both for assert not null. Yeah. Neither has to be assert not null. And we started creating reports like that. And you see that separation between components and unit tests. We gave this table of what we found. For unit tests, you don't have status checks, but here you see a list of things that we found without asserts. Not a lot of unit tests, so not here, but you can see that there was a jump in terms of test quality. So we started improving that. You don't see, you see the numbers 43 and 102, but you don't see comparison or something like working the pyramid model, something like that. But we are on the way. I'm going to say a few words about that in a minute. Also for that, like with document integrity, we found some confidence interval. We started thinking about a confidence interval, which is kind of how well your code is tested from our point of view, and multiply that by the line coverage. So you get like a score, which you can normalize and look at and see it improves, which is kind of nice. So this is the situation from like a few weeks ago, a bit more than that we have, but we're starting to expand the kingdom and we're starting to look at, first of all, more projects, because our experiment was very successful with the guinea pig and its brothers. And we're starting to move into more projects. But that means that we need a lot more foundation or infrastructure to do that. So if the beginning was just integration with Jenkins and sometimes semi-automatic runs of the tools and so on, creating reports and merging them, now it's built on an ELK architectures, collecting all the information, indexing it, and showing reports on it. We also have better CI integration because, like I said, things were running like sometimes semi-automatically and so on. things are getting more automated right now. So if you do something like that on your end, once things are showing promise, expect that you will need to do these kind of things. I mentioned that there's a second programmer going into our team. Part of his job is helping us with implementation of the integration of in CI. So what are we going to do next? We have a lot of ideas. I'm going to mention a couple of them. We're still focused on developer time and making it more effective, and therefore we kind of split it between two things to look at. One is the code itself, and one are the tests. One thing that we knew but didn't do a lot with was code complexity. From what I saw, people were taught to write in a code in a certain way, which kind of creates like very complex files. And we want to showcase that. We want to say, well, this is not how you should do it. You should split code to different modules. Not because it's new. It's because this is how you do it. It's going to be a better use of your time. So things that SonarQube already identifies is like long methods and long files. And we can do that, something with that. But jumping to point number 4 here, what if we could do it in terms of APIs? So what if we could learn about what is the total code of an API call in many cases, and then start talking about coverage and complexity, not just a method or a file or a class, because we don't understand the connection, what is getting called between those. But for an API, that means a lot. So we start thinking about looking at this, and this will probably require more code parsing and understanding, but we're planning to do something about that. The code and the tests have a lot of literals in them, magic numbers, magic text, strings that the problem with that is that you look at them and you don't say, well, is that really important? Why is that important? You get a strange ID you compare with, and you say, well, why is this ID important? So we want to flag those out. Again, making the code better. Making the code better, driving maintenance costs down. API coverage reports, I talked a bit about them, but we're going to continue as well. And currently we were just supporting JUnit 4 and 5 and Spring Boot. We want to do more about this because this is a bank, this is like a software factory, they have a lot of tools and frameworks and so on. We want to branch out as well. In terms of tests, we want better reporting. We start talking about this. Give numbers by types. Test redundancy. We talked about how you're testing your APIs, but if you're writing a test case like a different parameter, but you don't use all the parameters, you get more parameters, or you get multiple cases that cover the same code path maybe. So flag that. A lot of the code of the APIs just calls the mainframe, which is not part of the testing, this for now. So we want to show like tests for things without any logic in them. So are they redundant? At this point, yes, because they're not. These are tests that will always pass. We're looking at patterns in the test, like people use the assert true for equality, and instead of assert equals, you get better reports with assert equals. And also checking for error condition, checking for exceptions. Slow tests, looking at how performant the tests are. Not because of the code is going to be slow, but like I said, if you have a unit test, that could really be a unit test rather than a Spring test with loading all all kinds of just infrastructure, waiting a minute just to start running the test, and it's hidden in there inside all the API tests. That means we can get a better test organization. So we want to flag those out. And complex versus component or API tests. This is something that we want to flag out as well. Compare if you have like a workflow test that runs API after API after API, let's say 3 APIs. Check that if we have like separate APIs, separate single API tests, and see if we match, or maybe it should be broken into something like that. We're not always sure about what the suggestion at the end will be, but we want to try it and find out. Yeah, so that was long, and I'm coming to the end now. I hope you finished all your coffee. Before we finish, I want to talk about what I see are the success parameters for this. Why it worked and why am I not getting fired? And the team still exists and wants and gets asked to get more. First of all, it comes from management. Management wants and encourages not just more reports, but useful reports that will help the developers see better and make them work better. The goal of keeping the developer time, the developer effectiveness as main thing, it's like a guiding light, very important. There always should be a why you need to focus on that. You have to have the answer for that. If you don't, and it's like, yeah, SonarQube says so, developers will not play with you. They need to understand there's a reason why you're doing that, and it always comes back to their time, and you need to convey that. Show results early. The guinea pig was not just showing reports, but actually we showed results, and we showed results improving based on the cooperation of our project. And this played, and it kind of created confidence that it can be done with other teams as well. Transparency. We always said, both the development and management, what we're going to do next. So there were no surprises. The developers knew what they were going to look at. They understood why. They understood that it's not going to be used against them or something like that, and that they get a chance to fix something before management sees it, if there was such kind of fear. So that was very important for them. Finally, what worked is that we were running as part of the system. So we had management backing, we were working inside the bank, we were working with teams inside the bank that were working with us all the way. It's not like a consultant coming out from the out and saying you should change what you're doing A, B, and C. It was part of the system that wanted to improve, and that's why it worked. That's why I think it's continuing to work. So that's the story at this point. We'll see how we deal with questions soon. Information, you consider to get a link on the slides on Test Analyzer on GitHub under my account, and you can catch me at gil@testingil.com and on Twitter, and I'll probably be in the Ask Me Anything Zoom window soon. So for now, thank you very much.
Slido, I have a question here about, do you consider mutation tests in that suite when counting parameters? Actually, we didn't think about mutation tests at that point. That's an interesting idea. The reason I'm kind of saying, well, maybe this will not work, it's because we're testing a black box of APIs with a lot of code under that. Now, starting doing mutation, on one hand, that's true. On the other hand, some of them don't have a lot of logic to play with, some mutation tests. What will happen is that mutation tests won't have any way to play with. So it is an interesting thing to think about, but I think it will be most suitable for a specific kind of logic that we'll get to, but not at this point. It is interesting, though. The counting parameters, though, is kind of telling the developers, hey, there's something wrong here, without telling him that's exactly where you actually need to point. It's not usually a term of logic. It's more coming down to understanding the business requirement or the business case that you're actually testing. A lot of the time, not a lot of time, some of the time, for example, an example I gave with the API is that we had an ID parameter, and nobody could tell from the outside what an invalid ID is. But people who work within the architecture know the architecture and what the indexes are and what the IDs can be and should be. They can decide what to do with them. Also, there might be a case when the code doesn't do anything with them, just passes them on. So at this point, I wouldn't just jump into the code and say the code says something different. Maybe you should check that, because again, keeping the goal in mind, the goal is thinking about developers' time. And unless I have something that will say, this, or at least a pattern that we see that developers are not testing the code properly, or we see patterns of code that are not tested properly, I wouldn't jump into the conclusion, because having, I wouldn't say even too many mistakes in our reports, but having some of them will lose confidence in what we have. Like I said, what we're doing is running heuristics, which obviously can fail. But as time goes by and we get more confidence levels from the developers themselves and the feedback that we get, we might try new stuff like we're planning right now. So mutation tests is something that I'll keep in mind. Might be suitable in some cases. If you don't have any questions now, I'm now moving into the Ask Me Anything corner, so I'll be there, and you can ask me questions there. So that's the orange link under the browser. So I'll be there for the next few minutes and waiting for you. Thank you very much.